Hello. Hello, Sudhakar, are you there?
Yes, ma'am. Yeah.
Is everything set?
Yes, all set.
Okay, we'll start in 11:30.
All right.
Rupa?
Yes, sir.
We can
Shall
start?
we start? Yes. Okay. Good morning, everybody. Before we start, I'll make a simple announcement. We keep repeating that every day, but kindly mute your audios and switch off your videos to ensure healthy bandwidth and to ensure that while the speakers are speaking, there is no disturbances. And we'll also strive to make this seamlessly engaging experience. Minor distraction may occur due to technical glitches, so please bear with us. Good morning again. Very good morning, everybody. I'm Rupa, and today I feel extremely privileged to extend a warm welcome to all of you here this morning to celebrate this magnificent occasion. Productivity is never an accident. It is always the result of commitment to excellence, intelligent planning, and focused efforts. Every year on 26 November, we assemble to celebrate these excellences on grander scale in physical spaces. However, unprecedented times can't stop our spirit of celebration and National Metallurgical Laboratory's dedication to the service of nation. Therefore, we are here today to celebrate our hard work, our achievements, and the camaraderie that has been built over the past 7 decades. चारों तरफ इसी खुशियों की लहर में अपने सभी गणमान्य अतिथियों का हम स्वागत करते हुए हृदय की गहराइयों से उनका अभिनंदन करते हुए दीप प्रज्वलन के साथ आज के इस प्रोग्राम का शुभारंभ करेंगे। And we have the lightning of the lamp, please.
शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपो हरतु मे पापं सन्ध्यादीपनमोऽस्तुते दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः आरोग्यं देहि पुत्रांश्च मतिं स्वच्छामि मे सदा रवेरस्तं समारभ्य यावत् सूर्योदयो भवेत् रवेरस्तं समारभ्य यावत् सूर्योदयो भवेत् यस्य तिष्ठे गृहे दीपः सस्य नास्ति शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तु ते दीपज्योतिर्नमोऽस्तु ते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
Thank you. Moving forward, a formal welcome in our procedure. For this, I would request our director, Dr. Chattaraj, to please go live and deliver the welcome address. And I would request all of you to keep your audios off, except director, sir.
Thank you, Rupa. Very good morning to all gathered today. Today is a very special day, not only for National Metallurgical Laboratory, but for the country as a whole. It happens to be our Constitution Day, and we will take a pledge today during the course of this program to honor our Constitution. Also important for us, for all of us at National Metallurgical Laboratory, it happens to be our Foundation Day, and we are privileged and honored to have with us today Professor E.S. Dwarkadasa, one of the most eminent metallurgists of this country, who is a person with many facets, and we are very lucky to have him today. Professor Dwarkadasa has been a mentor for this laboratory as well as for different metallurgical institutions and industries across the country. And he has been a personally, I have felt a lot of gratitude for him, as well as on behalf of National Metallurgical Laboratory. A very warm welcome to you, sir, and thank you for agreeing to be the chief guest of this virtual function. I welcome all my colleagues from National Metallurgical Laboratory to this Foundation Day program. We have been under some hard times brought on by things that were definitely not in our control. And once again, this year also, we are forced to have this function virtually with a promise that hereafter we are definitely going to have an offline program, a program which will be where we will meet all our friends face to face. I also welcome Dr. T. Mukherjee to this program. He has also been another great mentor and a peer of this laboratory. There are many other distinguished guests who have joined this program, and I extend my warm welcome to all of them. National Metallurgical Laboratory is marching on has been taken forward by visionaries, and I'm sure it will be taken forward in the future by similar visions, similar ideas of nationalistic fervor that we are trying to inculcate through our different programs and in the minds of all our scientists and all our colleagues and employees at National Metallurgical Laboratory. Over the last few years, we have had a lot of industrial collaboration, and we are proud of that. In fact, as late as yesterday, we had an excellent industry meet where we were emphasizing waste to wealth issues, which has become an issue of great importance to this country, an issue of strategic importance to this country. We have similar such strategic programs ongoing at National Metallurgical Laboratory. We want to sustain those programs and build on it and take our nation towards self-reliance. Ours will, of course, be a very small contribution, but I'm sure these drops of water in a combined fashion will eventually bring about a deluge which will enable our country to be self-reliant, especially in matters of metals and materials. And that is the overall philosophy, the overall guiding principle that is driving us today, and we will sustain that. In fact, in this particular idea, Dr. And Professor Dwarkadasa has been a driving force. He has a very keen appreciation of whatever is Indian. He has a very good feel for India and Indian innovations. And we are all looking forward to Professor Dwarkadasa's speech and for his guiding words, for his advice, and for his instructions in the matters of technology and science. I'm not going to take much more of this of your time. Once again, I welcome you all. I wish you all a great Constitution Day and, of course, a great Foundation Day of National Metallurgical Laboratory. Rupa, I hand this over to you.
Thank you, sir. Thank you so much. As you said, today is another proud occasion. May I please request all of you to keep your audios off. Thank you so much. Thank you, sir. As you already said, today is another proud occasion to celebrate for the people of India. Constitution Day is also known as Samvidhan Divas and is celebrated in our country on 26 November every year to commemorate the adoption of the Constitution of India on 26 November 1949. The Constituent Assembly of India adopted the Constitution, which came into effect from 26 January 1950. Now, I would request Dr. Veena to please read out the pledge.
Thank you, Rupa. I request Sudhakar to please show the background. नमस्कार। अब हम प्रस्तावना की शपथ लेते हैं। हम भारत के लोग भारत को एक संपूर्ण प्रभुत्व संपन्न समाजवादी पंथ निरपेक्ष लोकतंत्रात्मक गणराज्य बनाने के लिए तथा उसके समस्त नागरिकों को सामाजिक, आर्थिक और राजनीतिक न्याय, विचार, अभिव्यक्ति, विश्वास, धर्म और उपासना की स्वतंत्रता, प्रतिष्ठा और अवसर की समता प्राप्त करने के लिए तथा उन सब में व्यक्ति की गरिमा और राष्ट्र की एकता और अखंडता सुनिश्चित करने वाली बंधुता बढ़ाने के लिए दृढ़ संकल्प होकर अपनी इस संविधान सभा में आज तारीख 26 नवंबर 1949 ईस्वी मिति मार्गशीर्ष शुक्ल सप्तमी संवत 2006 विक्रमी को इतर द्वारा इस संविधान को अंगीकृत, अधिनियमित और आत्मार्पित करते हैं। धन्यवाद।
Thank you, ma'am. Moving forward, it is indeed my moment of honor and pride to introduce our chief guest, Professor E.S. Dwarkadasa. Although he needs no introduction, as a director has already mentioned, he has been a friend, a guide, and mentor to NML always. Nevertheless, he is currently the chairman, CEO, and MD Karnataka Hybrid Micro Devices Limited, and held positions of honor in various academic and professional bodies. As chairman in Academic Council Virtual Academy for Ancient Knowledge Bangalore, Supra Energy Private Limited Bangalore, Cosmic Industrial Industries Limited Bangalore, NIPI Software Private Limited Mysore. He has also been Distinguished Professor RVCE Bangalore and Department of Metallurgy, Indian Institute of Science Bangalore, to name a few. He has been conferred with various honors and awards. Engineer of Year Award by the Institution of Engineers 2014. Metaserve International Award for Excellence in Electron Microscope, Institution of Metallurgists, London. Best Metallurgist Award of the Ministry of Steel and Mines and Indian Institute of Metals. Hindustan Zinc Gold Medal for meritorious work in non-ferrous metals and alloys, Indian Institute of Metals. NALCO Gold Medal for lifetime work in aluminium research, Indian Institute of Metals. And the list is long. He has more than 150 publications to his credit and also published numerous books. His area of specialization includes metallurgy and materials, fields of expertise, electronic materials, thin film device, failure analysis, physical metallurgy, mechanical properties, structural property, correlation, and microscopy. Sir, thank you for taking time from your busy schedule and marking this spectacular morning with your glorious presence. Sir, I'll please ask you to be online.
Yes, I'm online. Thank you very much.
We can't see you, sir.
Okay, you can see me now?
Yeah.
Yes,
Thank you so much, sir.
Right.
Thank you for taking time from your busy schedule and marking this spectacular with your glorious presence. On the occasion of Foundation Day, we have various set of awards for the continuous and dedicated efforts of our colleagues, and each of these category of awards are named in honor of our past directors of CSIR-NML, whose deeds and words have been inspired for generations. I would now request our chief guest to please felicitate our awardees. I'd like to name them one by one. Sudhakar,
yes.
Can we have the list, please? Yeah. Following are the winners of different foundation awards. Altaker Award for the best technology transferred, commercialized in 2020. This award goes for column flotation technology for the recovery of sillimanite from heavy mineral beach sand. And this award goes to Dr. T.V. Vijay Kumar and Ms. N. Basumati, both from Chennai lab.
Congratulations to both of them. I'm very happy to hand over the certificate to Drs. Vijay Kumar and Dr. Basumati.
Thank you, sir. Now next, we have Nijawan Award for the best paper published in the year 2020. I'll read out the names. This is Sri G.K. Bansal, Dr. V. Rajnikant, Dr. Chiradeep Ghosh, Dr. V.C. Srivastav, Dr. Monojit Datta, Dr. S. Ghosh Chaudhary for the paper entitled Effect of Cooling Rate on the Evolution of Microstructure and Mechanical Properties of non-isothermally partition steels. Congratulations to all the awardees.
Congratulations to all the awardees. Yeah. Dr. Bansal, Dr. Rajnikant, Dr. Ghosh, Dr. Srivatsava, Dr. Monojit Datta, Dr. Ghosh Chaudhary for this excellent paper. I must add here saying that I went through this paper in great detail and enjoyed reading it. Congratulations and thank you very much.
Moving on to the next set of awards. Professor Shilobhadra Banerjee Award for the best in-house project. And the project title is Development of Indigenous Air Stratifier for Dry Beneficiation. And the project, first I'll name the PL, Dr. Ganesh Shalavati, and the Mr. Abhishek Kumar, he's the co-PL, and the members are Mr. Kalicharan Hemram, Dr. R.K. Rath, Dr. Rajneesh Kumar, Mr. M. Uday Bhaskar Rao, Ms. Monica Sahu, and Mr. Pankaj Kumar.
Congratulations to the winners of the Shilobhadra Banerjee Award, Dr. Ganesh Shalwadi, Dr. Abhishek Kumar, Dr. Kalicharan Hembrom, Dr. Rath, Dr. Rajneesh Kumar, Mr. Uday Bhaskar Rao, Ms. Monica Sahu, and Mr. Pankaj Kumar. Congratulations for this excellent award for Shilobhadra Banerjee Award. Thank you.
Now, moving forward to the next set of awards, we have Professor S.P. Mehrotra Award for the Best Colloquium Speaker, and this time it has been jointly shared by Dr. Gopi Kishore Mandal and Sri T.K. Das.
Congratulations to Dr. Gopi Kishore Mandal and Dr. Tarun Kumar Das for the Professor S.P. Mehrotra Award for the Best Colloquium Speaker. Thank you.
And next in category is Professor P. Ramachandra Rao Award for the Best Employee, and this has been categorized into two groups. One is technical and the other is non-technical. For the technical group, we have two winners, Mr. Dilip Kumar Samurai from Engineering and Mr. Saroj Kumar from Applied and Analytical Chemistry Division.
I'm very happy to say that this award goes to Dilip Kumar Samurai and Mr. Saroj Kumar. I want to add here that Professor Ramachandra Rao was one of my very best students at the Institute of Science, and I cherish his memory all the time. Congratulations to both of you for getting this award. Thank you.
For the non-technical category, we have Mr. Anil Kumar from Administration and Mr. C.R. Chakravarti from Engineering.
Congratulations to Sri Anil Kumar and Sri C.R. Chakravarti for this non-technical category Professor P. Ramachandra Rao Award. Congratulations. Thank you.
Heartiest congratulations to all of you, and your contribution towards the goals and objectives of NML is highly appreciated. मंजिलें उन्हीं को मिलती है जिनके सपनों में जान होती है. मंजिलें उन्हीं को मिलती है जिनके सपनों में जान होती है. पंखों से कुछ नहीं होता, हौसलों में उड़ान होती है. Moving towards the next set of awards for the meritorious students for scoring 85% and above marks in ICSE and CBSE for class 10 and class 12 examination held during the year 2021. I'd like to name the students one by one. I don't think they have joined, but their parents have definitely joined. I'll name both of them. First one in this list is Mr. Sri Abhishek Shahu. He is son of Dr. got 97% in class 10th. Next is Miss Samiksha Sahu. She's daughter of Sri D.P. Sahu. She has also acquired 96.5% in class 10th. Miss Chayanika Chakravarti, daughter of Sri C.R. Chakravarti, and she has also got 96.25% in 10th standard. Next is Sri Shomajit Ghosh, son of Dr. Rachit Ghosh, 95.5 in 10th standard. Sri Devjit Ghosh, again son of Dr. Rachit Ghosh, 10th standard, 94.75%. Miss Sneha Shaw, she's daughter of Sri Ashok Kumar Shaw. She has received 93.5% in 10th standard. Miss Satyadeepa Pal, daughter of Sri P.P. Pal, 92.25% in 10th standard. Sri Bundu Samurai, he is son of Dilip Kumar Samurai, 88% in 10th standard. Congratulations to all of you. Now we'll move forward to Miss Deepanvita Ghosh. Next one. Yes, 12th standard, Miss Deepanvita Ghosh Chaudhary. She is daughter of Dr. Sandeep Ghosh Chaudhary. In 12th standard, she has acquired 93.5%. Next is Sri S.P. Ruchir. He is son of Dr. S. Shiva Prasad, and he has acquired 91.5 in 12th standard. Sri Abhishek Kumar, son of Sri. Is it, sir?
Yeah, I'm able to hear you.
Am I audible,
Dina,
sir?
if you can take over. We can't hear Rupa.
Am I audible
Dina?
now?
I can hear you.
Yes, sir, we can hear Rupa.
I can hear you.
Okay, good.
Okay. Can I continue?
Yeah,
Yes.
please.
Meena,
Please.
okay.
Yes.
Okay. Next is Shri Abhishek Kumar, son of Shri Manoj Kumar. He has acquired 91% in 12th standard. Congratulations to all of you. Sir, if you'd like to say something. These are all the meritorious students.
Now this particular, I really appreciate this particular award because it recognizes merit at a very young age and gives them fillip to do much better later in the life. I think I would like to congratulate all of them and wish them very well in their future studies. Thank you very much.
Okay. We have the next set of awards where the students have acquired 100% marks in any subject in 9th, 10th, 11th and 12th class examination, which was held during the year 2021. In this category, we have two students. One is Shri Abhishek Sahu. He is son of Dr. Jitendra Kumar Sahu, and he has got 100% marks in computer applications in class 10. Congratulations, Abhishek. Next one is Shri Shomojit Ghosh, son of Dr. Rachit Ghosh, another 100% marks in computer application in 10th standard. Congratulations to both of you. The last category of award is admission in institutes of national repute through competitive examination held during the year 2021. And this award goes to Shri Saurabh Hansda. He is son of Dr. K.L. Hansda and he has got admission in IIM Kolkata. Heartiest congratulations.
Congratulations to all three of them. The excitement at getting 100% marks can only be enjoyed and realized by only those who get the 100% marks. I remember in my college days when I got the first time 100% marks in mathematics, it was something beyond. I congratulate all of you and please do well and get 100% marks in all subjects and also get admission in institutes of national importance. Congratulations. Thank you.
Thank you so much, sir. Finally, I would request our chief guest to please go live. We have been patiently waiting to hear from you, sir.
Thank you very much. Let me say thank you to both Rupa and Beena for doing a very excellent job and telling people something about me which I don't know, I myself didn't know. Thank you very much for that. First, let me say good morning to everybody. Dr. Chattaraj, especially good morning to Dr. Mukherjee. Dr. Mukherjee, I missed you at the last meeting in Dhanbad last week. There's some background noise.
I did not know I was supposed to go. But
Pradeep was telling me that Mukherjee is coming, but I didn't see you there.
Yeah. I somehow missed.
Yeah, that was the end of the 75th year of the CM Sinford, right? Excellent. Dr. Chattaraj invited me to be chief guest at the Foundation Day ceremony of NML, the 72nd. Initially, I thought I've been there in so many places. Why again? And the NML people know me already. They've seen me so many times. So why again come back? But then I thought, among the various CSIR labs that I've been associated with, NML is slightly different, slightly very special to me, because the first lab I visited after my graduation in metallurgy was NML. At that time, Dr. Nijawan was the director, and later he became my examiner also for the master's degree. So I had a very good interaction with him. Also because Nijawan and my previous professor, chairman of the department, were both from NML, Dr. A. Krishnan. So that's the time when I got introduced to NML. And later on, I abstracted the NML journal for the chemical abstract, so I kept continuous contact with it. I also was very excited to see the excellent work being done at NML in those days. Nickel-free stainless steels, high conductivity aluminum alloys for electrical applications, the low shaft pig iron furnace, the pilot plant, all these very, very exciting things at that time. And more recently now, I think there are so many very exciting things being done. I think one of them is the e-waste recovery and treatment. Only yesterday morning, there was big news in the local newspaper here, saying that all the IT firms are sitting on ticking bombs, namely the e-waste. So that is going to assume a large importance, and I'm sure NML will come in a big way to solve this problem, to attack this problem. They're already doing it. I know about it, but I'm sure they will do many more things. More than that, several NML scientists have been my students. I can name some of them: Professor Ranganathan, who recently retired, Dr. Venkateshwara Rao, Dr. P.K. Biswas, Dr. Srikanth, and several of them. Dr. Bhattacharya. Two of the earlier directors were also my students, Professor P. Ramachandra Rao and Dr. Srikanth. So it is almost saying I'm coming back to NML to my own institution. So I said, okay, let me talk to the scientists and tell them something about what I'm doing now. First, I thought I'd take a very technical subject and give a lecture on that. Several things I'm doing. I'm doing one on dry sliding wear of materials, trying to find out how from the sliding nature, sliding wear, you can determine various properties of materials. I'm doing that work also now. I'm also working in the area of rare earth challenges in the country, working in the area of energy, namely hydrogen. And one other thing which I'm working is in the area of metals. Metals in the sense, how far ago did we know about metals? How did metals contribute to the development of civilization? The work is not complete, but I thought it's better to introduce the subject. If somebody is interested, I think we can also collaborate and we can work together on that. And let me share my open share tray. Then how do I get it? Is it visible? Is my slide visible? Okay,
No, not yet.
No, sir.
I have shared the thing and I'll come back here, so I don't know. Where do I? Maybe the procedure I've used may not be correct.
Maybe just go to share content and click over here. Just follow this cursor, sir.
One second. I'll end the show now first. I've ended the show. I've minimized the screen. It says desktop window. Click on that. No. Choose what to share. Entire screen. Okay, very good. Share. If I now come, you will see now, and let me open it and see if you are going to see that. Can you see now?
No, we are not able to see yet.
Not able to see yet. Let me, maybe my procedure is wrong, but let me go back again.
Sir, first you open your presentation.
Yeah, I opened the presentation. I have done it.
Yes, Dr. Dwarkadas sir. You just open the presentation,
Okay.
and then you start sharing the content. First you open it in your browser.
No, I opened it. Where do I say share? There's nothing say where is shared.
In the Teams meeting only, sir, there will be an icon. Just
No, the icon comes first.
So if you go to the bar.
One second, let me just. Oh, what is happening? I don't know. There's something happening. One second.
So next to the microphone icon, there's an arrow.
Then all that comes before I open the presentation. When I open the presentation, It is showing the whole screen. I don't see anything else.
Sir, if you can go out of that screen and minimize that screen.
Yeah, I minimize the screen.
Now you can see the Microsoft Teams.
Yeah, I can, but there's another image that has come. Choose what to share. Team Muscog wants to share the contents of your screen. I said entire screen.
Fine. If you can click on that.
If I click on that, it says cancel.
Chaturaj sir, we can share the screen if you have the presentation.
I have the presentation with me.
So if you can mail it to Sir, Indranil sir, we'll share it.
You want to do that? Okay, I will do that.
We can do that.
I will do that. 1 second. Let me see what. One second, please. 1 second, please. Are you able to see now?
No, sir.
No, okay. Okay, I'll send it to Indranil, and you can send it from there.
Sure,
Sir,
sure.
I'll do that. I'll do it.
Sure.
I'll go to my. Reply. Attach. Feelings of man.
इसका बैकग्राउंड आ रहा है
Yeah, did you receive? Okay.
Kindly mute your audios. Rest of you who are not concerned, please.
I sent it. I've sent it.
So did you send it to iChat?
No, I sent it to you. You sent me the program. I replied it from there.
Okay.
So after making a full screen, try Control F5.
After making a full screen, say share first. Go to full screen. Okay, and then say what?
Control F5.
Control F1.
F5.
What is that F5?
F5.
Oh, say one second. F5. Yes. I did it. Nothing happened. Control F5. Nothing happened. I think Dr. Chaturaj can present it on my behalf. Here I can see that it is saying screen share.
Yes, sir. That screen share, you have to just open the presentation and screen share.
No, I have opened the presentation. The presentation is open already. Can you see it now?
Sir, while you are clicking on the share content, can you see the screen and at the same time right side window?
No, I don't do sharing. I don't see.
You will get two options. Once you click on the share content, you will get two options. Either you can share your screen or you can share your window.
You
click on the window. You click on the window, and from the menu you can share
Watch
the.
once.
If I click on the window, I see here, choose what to share. It says entire screen.
Presentation.
Bhaskar, if you may take control of search system.
How about you now?
It's visible, right?
We can see.
Good.
Yeah, we can
Oh,
see now.
yeah, okay, now you can see. Fine, thank you. I will put it on presentation mode.
Exactly.
Okay.
All set, sir. All set.
I'm sorry about the
Thank you,
confusion.
thank you.
I'm very sorry about the confusion. Now let me start. Thank you for the patience. I gave this lecture quite some time ago because I started working on this for the last 2.5 years now and finding very exciting things in the literature. I named it The Beginning of Metals and the Growth of Civilization because civilization seems to have grown very closely with metals. Metals seem to have contributed to this growth. And so I thought this may be a very nice title. Before I proceed, I would like to pay my obeisance to my guru, Professor Lakshmi Dattachar, who brought me in contact with Sanatana Dharma and then encouraged me to work in the area of metals and metallurgy in ancient times. We lost him recently to COVID, and we are very sorry about it. But he guided me for almost 25 years in this particular area. India is one of the oldest civilizations. The history the history and the ancient Indian culture begin with the Indus Valley civilization. While I present several things to you, some of these data have been obtained from some of the manuscripts that we are looking at. There are several complications as well as contradictions. So please do not worry about the accuracy of some of the statements I make. Some of them may be very qualitative, some may be quantitative, but I do not want to claim any accuracy of any of these data. This is only to make a presentation of what I found in the last couple of years, and just to encourage people to come and join me in going forward to find some of these solutions and answers. But India has been endowed with very rich sources of ores and minerals, and it has also it had become the leader in metallurgy in very early times. Everybody knows that. The word metal itself is very exciting to me. As you know, that I'm a graduate in metallurgy, and I took a very deep interest in study of metals, and therefore I think study of metallurgy can take you everywhere. The story of metals and metallurgy is even more exciting. Very interestingly, I found that metallurgy was separately mentioned as a subject in the 64 Vidyas that a student has to learn in olden days. The first metal to be discovered by man must have roused his interest, for instance, for its multiple uses. Even today, many of the technological advances depend on the use of one or more of these metals. There's a very difficulties and counter arguments about these claims and so on. So I don't want to make any claims. I simply want to say that science and technology in ancient India covered many major branches of human knowledge and activities, including mathematics, astronomy, physics, metallurgy. I've put a different color to show the importance, shipbuilding, navigation, and so on. Science and technology had reached a very advanced state of development in India. Metallurgy, in a way, was the backbone of all such developments. There's a modern definition that a metal is a chemical element with very specific properties, namely being a solid at room temperature with a very specific structure, electrically and thermally conducting, elastoplastic, that is ductile, malleable, and so on, and when freshly fractured, gives a lustrous surface. Most metals are silvery white in color, except gold and copper. Gold is yellow, and copper is brick red. this combination of properties is not usually found in many other metals. Some student asked me, graphite is conducting, but it is not plastic. Something else is plastic like clay and so on, but it's not conducting. So the combination of properties is what identifies a metal. I just thought this is a very beautiful presentation I took from Google. It indicates so beautifully all the areas, alkali metals, the alkaline earths, the lanthanides, the actinides, the metalloids, the transition metals, post-transition metals, and the gases here, and the noble gases. So I thought it's a very beautiful way to even to very quickly remember all these things. I just put it in here to show the mostly the metal part, the blue color and the yellow color. Of the 109 elements, 84 are metals, so the majority of them are metals. Of these, 24 metals were known before the 19th century, 12 were discovered in the 18th century. In the pre-Common era, BCE, only 8 metals were known to us. These two are the most important ones. For almost 1800 years, there were no new metals discovered. That's what is important. The earliest discovery seems to have been around 6000 BC. I told you don't give too much attention to these numbers, but it simply says that we knew it for a very long time. Copper, gold, and silver were the earliest metals known to man. And immediately you will know why it was so, because copper was red in color, gold was yellow in color, so easily recognizable. And also, these metals occurred as pure metals, with almost no impurities. It is called native metals. And when the copper occurs as a small little object, it's very easy to identify it by its color. Iron is known to have been used in early pyramids and perhaps obtained from meteorites. Again, we still do not know when and how. I prepared this table from out of the data that we collected from a variety of sources, but none of them is very definite. Therefore, it's only an approximate period here. But the order approximately seems to be okay. It is in this order that we knew how we discovered metals. Copper, gold, silver, all about 4,000 years, 4,000 BCE. Lead, bronze, about 3,000 BCE. And iron, zinc, tin, mercury later. There are some very recent dating programs that have identified some slag particles taken from places of iron production long ago, to say that these slag particles indicate the date something like 12,000 to 18,000 BC. Since we are not interested in the periods now, we will not worry about it. We'll simply say iron was known to us for a very long time. The reason why I have put bronze in red color here to show that when copper was started to be extracted, it always had certain impurities, mostly zinc, tin, and so on, and the product was yellowish in color rather than red in color. At one time, people even thought they had found gold, or they were able to make gold, and so on, and therefore the bronze existed for a fairly long period as a material that was used for a variety of purposes, especially tools. The early man knew how to make use of these metals because he knew they had different properties from the other materials. At that time, they used stone, clay, pottery, and so on, and the properties were very different. So they said, let's make use of these metals for certain purposes which we can't use other materials. Copper appeared more important as it could be made into useful tools. When you say tool, we need hardness of the material, and it should be harder than the material that you're working on. So copper lost it. Silver was used for making jewelry and monetary units, coins, especially because when you take a silver piece and flip it up, it gives a metallic noise, and that noise perhaps was the reason why they used it for coin making. I've written also coin-like pieces because there are so many awards given which are looking like coins but were not used as coins. Iron was used for making strong tools and weapons, but in terms of history, the tools of iron come much later than copper. Zinc and tin were used to make copper stronger, and these were copper alloys. There was several questions that arise in my mind. It still is there in our mind without answer yet. How far ago did we know about metals? How did they differentiate the metal from non-metal? The early man. How did he differentiate it? How did they know that each of the metal was different from the other? How did they discover how to extract the metal from the earth? I've written here it's as earth. It actually means it's a mineral or ore or something. We have just now said we knew these metals that we will call them prehistoric. 0 to 18, this period, 18th centuries, we discovered only antimony, arsenic, and platinum, and then all the other. We call them 18th century, 19th century, 20th century. All of these metals were produced in the last 300 years or so. We would like to go back to the origin. While copper, gold, and silver picked up as naturally occurring nuggets and used, other metals seem to have evolved by several accidental observations. We have one very, very interesting incident to show that it was an accidental observation. I will be talking about it. While they looked for more metals, those metals that were abundant and easily reducible by charcoal or carbon were accidentally discovered. This is very easy because at that time they did not know any thermodynamics or anything. All they knew was how to put out a fire, how to douse it, and then take it out and take the ash and so on. So we have to have something that takes place in a very simple fashion. So we had to look at oxides that were easily reduced by carbon into metal, and that metal was being seen by these people. So we are looking at one possibility. There's no evidence for this, but this is one possibility that comes out from some descriptions in some of the maps, in one of the maps. Possibility of metal extraction. Just imagine the nomads were moving from one place to another. They were roaming communities. They would put up camps and fireplaces for cooking. The fireplace was a hole dug into the earth and charged with twigs, charcoal, etc., and blown with air for the high temperature. On the eve of moving, the fire was doused, and all the contents of the fire pit were emptied. If the earth around the pit contained some ores of these metals, it would have been converted into metal because of the carbon that would come out with the ash and be discovered as shining metal particles. We think this could be one of the ways, one of the accidental ways in which they said, hey, there is some metal which is different from the rest of the materials, and start looking at it. So having learned that fire gives rise to metal particles, the keen observer would have begun to devise methods of getting larger quantities of the same material, the metal, by repeating the same process with different earth samples, leading to the discovery of ores that yield the metal. It appears obvious now because we know a lot of things about metals, extraction, and so on. Based on that, now we can go back and imagine that the early man must have stumbled on easily reducible metal oxides that got reduced by carbon to result in the metal. And these are iron, copper, zinc, lead, silver, and so on. I've not added gold here because gold is always available as pure gold. It is possible that this process must have taken tens or even hundreds of years before performed. Our sources of information, we want to be a little careful and find out where can we get all this information. We then found out Vedas, perhaps the oldest. There are names of metals indicated, and these names themselves will give us some idea about the origin of these metals. For example, they were talking about the ant gold. Chikili Swarana something, which means the ant brought it out from the earth and put it up in the ant mound. And when people looked at it, they got the gold, and they were the purest form, etc. So the names could also mean names also could give us some idea about the origin of these. The Puranas and the epics, the Ramayana, Mahabharata, Bhagavata, and so on, all the 18 number, they also contain a lot of information about uses of metals, and therefore we can look at it. Historical records. There are several records available, but only for periods about 500 BC and later, and some of these are not very accurate. So we are saying, if you are looking at the historical records, please check on their correctness or accuracy. Coins and coinage are very, very important. For almost 3,000 years, they have been in use, and these coins and metals used for coins and coinage will give a real reflection of growth of civilization. There is an excellent book on coins and origin of coinage. I forget the name of the author, but it gives a whole lot of information about coins. Travelogues. These are very important records. Records that are written by travelers. I think I'm going to repeat some of these in my future slides. Don't worry about it. They give accurate accounts because it was written by somebody who saw something, went back and wrote it and said, this is what I saw. Archaeological evidences. These are the best evidences to indicate mastery in metallurgy. This is roughly about 2,500 years, for the last 2,500 years. Stone metal inscriptions. These are inscriptions put up by various rulers and so on, and they give very accurate descriptions of various events, and therefore are very reliable. So when you say Vedas, only 3 days ago I read about the 4 Vedas, what do they mean and so on. The interpretations are really astounding. These Vedas perhaps contain the oldest information. We do not know the date, but we'll simply say chronologically they may be very old. Records of procedures and processes. For example, Rig Veda says all these procedures of how to use the metal, how to use a material, and so on. It gives the earliest reference to astronomy also. And there it says roughly 4,500 BC. The Vedas give data in the form of poetry, aphorisms. I must definitely explain what is this. During those days, most of the scientists were rishis, and they said any knowledge that we gain should not be passed on to anybody. It should be given only to those who have master control over the mind, and therefore will be able to use the thing for public good and not use it for public damage. And therefore, the knowledge was not given directly to anybody. It was all hidden in ephemerisms. Today, we find that difficult. Whenever I see a shloka, I can say one of those. This is a process of purifying gold, which appears in Purusha Sukta. Whoever knew what this is, when you just read the Purusha Sukta, you will never get that idea. So like that, many of these procedures have been hidden in poetic form, and it needs some real Sanskrit scholar to decipher them. And that's one of the reasons why we are not able to get much of the data. Today's Sanskrit scholars are very good in Sanskrit. The scientists have no Sanskrit knowledge, and the person who has both the knowledge, there are very few of them. And therefore, the progress is very, very slow. Inscriptions are, in fact, the best sources for us. These are the most reliable evidences. These are mostly carved on gold, silver, iron, copper, bronze plates. They're on stone pillars, rocks, temple walls, and etc. These are free from interpolations. Inscriptions in Prakrit, Pali, Sanskrit, Telugu, Tamil, Kannada, and other regional dialects have been discovered. But most of these inscriptions are in Brahmi and Kharoshthi scripts. So we need knowledge of these to decipher them. They give very valuable information regarding the extent of the kingdom and administration and so on. So when you are looking at growth of civilization, these become very, very important. The reports from various travelers give knowledge of ancient Indian history, and they are supplemented by the writings of several of these people. Prominent among them are the Greek travelers. That's how the names given here. Megasthenes, and so on. Who wrote the Indica, Chinese scholars, Faxian, Hunsang, and so on. And there were several Arab travelers that are not mentioned here. And these travelogues they're all available and they're very valuable sources for us. I mentioned about coins and coinage. We support accounts given in Purana. That's the thing that we wanted to make use of. All the coins and coinage will try to support what is described in Puranas. The earliest Indian coins found are punch marked. I made it here to say when these tools have to be used, they have to be metallic, harder than what you are doing. You are producing the coin. The silver and copper pieces, usually square or rectangular. You will be surprised that these coins became round much, much later. I'm sorry. Because of their properties, gold, silver, and copper were also used to make artistic jewelry of all sizes and shapes. Some of them you'll be wondering why they made it so big. They were very, very large ones. Particular patterns seem to suggest the time period to which they belong. Pure gold, pure silver, alloys of gold with copper and silver, and with copper, as well as gold, silver alloys were used at different times. The kind of alloys also will give you some idea about the timing of these materials. Literature and I just mentioned a number of these, but for metallurgy, there are so many of these treatises from which you can get information. Rasaratnakara, Rasa means mercury. Rasaratnakara, those descriptions made based on mercury. And these are extensive, very extensive. In fact, when we are trying to write the potions made of gold, we got some 150 descriptions, different descriptions of medicines based on gold. And they're all described in Rasaratnakara. So we are now talking about a variety of literature in which metals have been used in a variety of ways, and therefore we get information about metallurgy. An important Indian metallurgist and alchemist was Nagarjuna. I think this name is very familiar to everybody. In 900 BC CE, who wrote these treatises of Ratnakara. We also should not forget the alchemist, who tried to make gold thinking that they can convert all metals into gold, especially copper, silver, tin, etc. Apparently, they ended up making some kind of alloys which looked like gold and therefore thought they made gold. But later on, it is described that gold cannot be made in any other form than given by God. That's what it says. We found this description in some particular literature. So we should look at all these very, very carefully if you are looking at information for metal. Just to repeat some of these, gold is the oldest of metals known, occurs in nature as pure metal, easily recognized by its color, the golden arrow, easily separated from sand, etc. due to its high specific gravity, non-corrosive and retained shine forever. Did not have enough strength to make into tools and weapons. Copper had a different property. It was another one of the oldest metals known, occurred in nature as native metal, pure metal. When not very pure, was harder or stronger, could be made into tools and weapons, easily mixed with gold and later with other metals, particularly silver and zinc. Why we say copper objects is because there are thousands of these available. For example, lamps in the temples, most of them made of copper and copper-based alloys. Tonsure was a very important ceremony for boys at the age of 8 or 10, and the tool used for that contained copper. Copper was a component of the razors for the tonsure ceremony. So you can say, foresee, I get an origin, a description of copper, not in copper, but in this tonsure ceremony, and it decides what kind of tool was used. I get information about copper there. One of the most important sources of history in the Indian subcontinent are the royal records of grants engraved on copper plate. It's called Tamra Shasanas or Tamra Patras. There are so many of them. And these give you extremely important information. But what is important here is it is written on copper. That means copper was available in plenty to do this job. And they also knew when you write it on copper, it lasts much longer, very long. Silver is also found in nature as pure metal, named the native metal, and as nuggets. The form in which copper, gold, and silver are found as pure metals, all three are different. They're not the same. It is identified by silvery white color, shining white color. It produces a metallic sound when allowed use as coins and monetary unit. You have to really experience this metallic sound. Compare it to the other metals. What silver gives you is a very, very beautiful sound. It is easily alloyed with copper and gold. Extraction from ores of lead to identification. The extraction from ores lead to identification of lead because lead occurs mostly with silver. Zinc is very exciting material because zinc has a low boiling point, and therefore when you extract it, you get zinc vapors, not zinc metal. The zinc oxide is easily reduced to zinc metal, but at the temperature reduction, zinc is volatile. It is such a surprise that early Indian knew. Where did I go? I'm sorry. It is such a surprise that early Indians devised a method of collecting metal by allowing it to condense. Only 2 weeks ago, I met a person from Hindustan Zinc who had said he has records some 3,500 years old, and in that he has found how they designed the crucible to extract zinc, in which the zinc, when it evaporated, coated on the top surface of the crucible, and they could scrape it out from there. So there is some development that's very exciting. Zinc was used to alloy with copper to produce stronger materials like brasses. India reached a premier position in the extraction of zinc and exported the metal to different parts of the world. I have not put any date here, but I'm sure it is 3,000 years or more. Lead was a byproduct. It always occurred with ores of silver and zinc. So when you extract silver or zinc, you also got lead. And it was identified as melting metal, very heavy, very high specific gravity, changed the properties of silver and brasses when added to them. And very often they did not know that the silver or other material that they were using contained a fairly large amount of lead. We cannot mix descriptions of iron in this general talk here because iron seems to have gained importance in a very different way. It was very hard, easy to produce, and they could treat it, thermally treat it to get many properties. So it had been identified as ayas, that means obtained from God, and it was taken from the meteorites. Beads found in pyramids seem to have come from these meteorites, and they are iron-based alloys. Because of the abundance of iron ores in the Indian region, chance contact with burning coal would have produced the metal. We think so, we don't know. We don't have evidence to prove this. The production of iron in large quantities became possible very quickly because of the abundance of iron ores in India, the Indian subcontinent. I just took this from your own A.K. Vaish and P.K. Biswas and others. They wrote an article on prehistoric iron making, and I just took it, a small little thing. The main reason why I want to show this is we have one like this very close to Bangalore, and we took a slag sample from here and got it dated. It turned out to be 5,000 BC. And therefore, iron must have been known for a very long time. That's why I thought it's very interesting to see this little thing. Please look at your paper from your colleagues, A.K. Vaish and P.K. Biswas with us. Whenever we talk about metals, we cannot forget the Delhi iron pillar. It is supposed to be called the rustless wonder. It has been standing there for 1,600 years without rusting. The term without rusting for a metallurgist is different. Without rusting means it is there for a long time with no change in big dimensions on. Some rusting will always occur on this. And there are inscriptions on this. If you can properly read it, it says This was brought from somewhere and put in this area in Delhi as a symbol of victory. The top portion here had gone off and it has been rebuilt here. If you look at the description by Anant Raman or somebody who has written about the restless wonder, you will get some idea about this Delhi Iron Pillar. What it says here is that we were such experts that we could make such a huge pillar, almost weighing about 7 tons, without anything like crane or other thing. We didn't have any of those, but they were able to do it here. So there's a very excellent description of how you can build tall structures. The same would have been used in making this Delhi Iron Pillar also. Description of Delhi Iron Pillar itself will become a very big lecture. We would not like to forget about our heritage in steel making. We will skip all the details and directly go to this wood steel. This was the acme of mankind's metallurgical heritage. Woods were the first high-quality steel made anywhere in the world. And according to reports of travelers to the east, the Damascus sword were made by forging small cakes of this steel that were manufactured in southern India. And this steel was called wood steel. Woods is simply a variant of ukku. Ukku is the name of steel in Canada, where it is made in the southern India. This paragraph is sufficient for you to give a very huge amount of information about what kind of knowledge we had about steel making. At that time, they did not know the word steel. They called it by a variety of names. It should okay. We would like to also say that we had gained so much knowledge about steel, we were recognized as leaders in steel making. At that point of time, nothing produced in Europe could match the quality of India's wood steel. And India continued to be the leading nation for steel production in the following centuries. During the late 17th century, for example, wood steel was being produced at almost an industrial scale, as tens of thousands of steel ingots are being shipped from the Coromandel coast to Persia. Somebody asked me, when you are saying tens of thousands of tons are being exported, how did they make it? Please note that they did not make all of it in one place. There were actually tens of thousands of places where they made it, and they were all together. And therefore, there was consistency of quality of steel production. That's a very important information that we should remember. So if you want to now make 300 million tons of steel, you can't make 300 million tons of steel in one place. You should make it in at least 3,000 different places and bring them together. And that is the way it was done before. It was only during the 20th century, after decades of experimentation, that the science behind the production of wood steel was understood. Indeed, it may be said that the methods of ancient India were, technologically speaking, way ahead of their time. Although I've said that decades of experimentation, they found it out, even today, they have not been able to reproduce the structure of the Damascus steel. There have been many experiments to reproduce it, but not much success. The technique of producing the wood steel was a closely guarded secret amongst the metallurgists in India for a very long time. This term long time is almost, I think, 7 to 9 centuries. Thus, the Indians had monopoly over the production and export of this highly desired metal. The steel produced in India was exported in the form of ingots, reached places such as the Roman world in the west, the China in the east, and the Arab countries. You could give. I'm not written much about iron here, iron and steel, but there are enough literature talking about iron and steel in the last 2,000 years in India. I don't know why I added this here, it doesn't matter. The process of making woods is conservatively estimated to be originated in South India in roughly 400-500 BCE. This most famous of the true Damascus was used to make steel weapons through the 7th century Christian era, by which time smiths in Damascus and probably some other areas had learned to produce this high carbon steel themselves. Woods, Damascus blades processing the highest quality Damascus patterns were produced in the 16th, 17th century. The art of making the blades has since been lost. Just to show some things, I've taken this from the book from Raghunathan and Sharda. They've shown these structures. What is important here is to know that these steels were not melted. They were always treated in a semi-solid state, and they were able to put in almost up to 2% carbon in the material. So they had two types of it, one very high carbon steel and another low carbon steel, but still were able to produce very similar structures, either of martensite or of ferrite. No discussion on metals will be completed unless we talk about the mastery in casting that the Indians had reached. I'm only showing here some examples to show how they had mastered the casting art. This is the Nataraja. I've given some place where I took it from. This Nataraja is a complete figure without any joints and is known to be produced by the last pack process. And this is something slightly different. There are some joints here, but the different one, but looking fairly similar. So this type of mastery in casting was the metallurgists had acquired it, and they were able to cast all kinds of metals. I'm sure you will know there are so many of these gold castings that are seen in the temple in Thiruvananthapuram. So I want to show just some more of these to show the mastery in casting that they had achieved. That was this beautiful thing by the last wax process. The sculptures in temples, when you say temple, automatically it sets you down to 2000 years. I understand, and we have also read in some literature, that the temple architecture started blooming when Hindus and Buddhists, and of course Jains, they coexisted for 1,000 years from 0 to 1080 or 1280. That is a period when temples really evolved, and at that time, the sculptures in various temples will show you that they had used excellent tools to produce these artifacts. These artifacts come to us right since Indus Valley civilization that belong to Chalcolithic and Copper Age, but that's followed by the Iron Age during the Vedic period. I've written this term Vedic period without looking at the time period, but it doesn't matter. This is important. For the Copper Tools Age, we have moved on to Iron Age, and the tools here are much stronger, and therefore we can produce much better sculptures. Indian sculptures are one of the earliest instances of sculpting in the world. India produced some of the most intricate sculptures, and these are unraveled in the art during Hinduism, Buddhism, and Jainism. That's what I mentioned. This period was most important for temple development. The carvings and sculptures in the temples and elsewhere. Okay. I'm sure everybody knows about this because so many people make use of this. This is Dancing Girl from Mohenjo-daro. I just wanted to add it for this particular purpose to say this famous Indus bronze statuette, the slender-limbed dancing girl found in Mohenjo-daro, it evoked the following comment. Difficult to believe that they are prehistoric. They seem to completely upset all established ideas about early art. What it means here is that we can say we were good in metallurgy during some time and so on, but if you look at this, which was obtained in Mohenjo-daro, known to be belonging to the Indus Valley civilization. So the time periods get completely mixed up now. If I say I knew copper for 3,000 years ago, this statue, if it is made of copper and zinc or something, it'll upset your calculation. So we are now taking a relook at the whole thing to find out where we can get information about the origin of metals in India and how they contribute to civilization. I think I have one more. This is the last one, I think. As metallurgists, you will always ask the question, how did they handle the metal? How did they melt it, pour it, and so on? So there's a very special treatise on how they made these vessels for handling the metal. Today, the term crucible is a very new name. They had a very different names, but they have descriptions of contents, the containers that could handle molten metals. We'll say I've written here some description which is more recent than the old one. Simple clay crucibles were used for metal melting, which was efficient. You can see that clays and metal melting, we are looking at low melting metals. Later, they discovered the refractory, and that we'll go to higher melting metals. Day by day, the developments in refractory and ceramic contribute to the innovations in efficient crucible manufacturing and metal melting practices. So this paragraph will tell you that we started with material to hold low melting metals, went to higher melting metals, and went to very high melting metals. And today we know we can handle even very high melting metals. In ancient times, steel and iron were difficult to melt using charcoal or coal fires, which could not produce temperatures high enough. So we are talking about here how the thermal processes were used to extract metals. I think that's my last slide. I only want to say every day our study is bringing out new facts. Some are surprising, some are astounding, and some are intriguing. We continue our quest. I'm continuing this, and we have now produced the 7 monographs of these 7 metals. We are now trying to finalize it and publish it. When published, we'll let you know. You can also take a look at it. We'll make it available to everyone. Thank you very much. Thank you for your very patient listening. Thank you.
Exceptional presentation, sir. This was so enjoyed by around 150 participants who are on this platform, as well as many others who are seeing this through YouTube. This is a presentation we would like to preserve. With your permission, we will archive this in our archives itself.
Please, sir, please do it. But
you.
I'd like to say that I'm just rewriting my metal records, and possibly you archive it now, but I will probably give you some more information to add on to it, maybe in another 2-3 months' time.
That would be great, sir. That would be great. Thank you so much. Rupa?
Yes, sir. Yes, sir. Thank you so much. Thank you for such an insightful and enlightening talk. But now moving ahead, I request you, sir, and our director, our AM, Dr. Sinha, to please switch on your videos so that we can go for photograph. I think I saw Dr. Mukherjee also somewhere. If he can join.
You should allow me to switch on my video. It's off.
Yes, sir. Please switch on your video. Just
no, I can. You have to allow me. I cannot do it.
Okay. Okay. Sudhakar.
Yeah, I am having.
Yes.
It says that it has been switched off by the host.
Yeah, now everybody can get. Now we give the right to everybody to turn on their audio and video facilities.
I'm still not able to do it. I'm sorry. Oh, okay, I can do it now. I'm sorry. I can do it. Good. Dr. Mukherjee, it's very nice to see you. You are muted.
Nice to see you, Tarak.
Yeah. Thank you very much.
Please go ahead.
Please.
We will superimpose my photograph at some other point.
Sure, sir. No worries. Now moving ahead, I would request our AM, Dr. Arvind Sinha, to please deliver the vote of thanks.
Namaskar. Am I audible, Rupa?
Yes.
Yes, sir, you are.
Yeah.
Yes.
Okay.
Rest of you can please switch off your videos.
Yeah, धन्यवाद रूपा. आदरणीय प्रोफेसर द्वारका दासा, आज के प्रोग्राम के मुख्य अतिथि डॉक्टर इंद्रनील चट्टोराज, निदेशक NML, प्रोफेसर मुखर्जी, डॉक्टर टी मुखर्जी, हम लोगों के मेंटर, सभी प्राइज विनर्स, उनके और मेरे सभी साथी NML के, आज मेरे लिए अत्यंत हर्ष, गौरव और सम्मान का विषय है कि अपने संस्थान के 72वें स्थापना दिवस पर मुझको धन्यवाद ज्ञापन का अवसर प्राप्त हुआ है। और इसके लिए मैं सबसे पहले अपने मुख्य अतिथि प्रोफेसर द्वारका दासा का हार्दिक धन्यवाद देना चाहता हूं उनको कि उन्होंने अपने व्यस्त समय में से ये समय निकालकर हम लोगों को अपने आशीर्वचन दिए और एक सनातन काल से लेके अभी तक के समय की जो कंटेम्प्रेरी टाइम है उसकी धातु के साम्राज्य में यात्रा करा दी। सर, ये वाकई में बहुत ही सौभाग्य की बात है कि अपने वेदों को जानना, वेदों को, वेद जो बेसिकली एक विज्ञान और विज्ञान का भंडार है, उससे कंटेम्प्रेरी साइंस को निकालना और उसको आगे बढ़ाना। और मेरा विश्वास है कि वर्ल्ड मेटल में मेटा छुपा है। मेटा मीन्स बियॉन्ड। तो हमको लगता है कि आने वाली कई सदियां धातु विज्ञान के क्षेत्र में नया और नया अनुसंधान देखेंगी, उसकी नई और नई उपयोगिता देखेंगी जो मानव समाज के लिए आगे जाके हितकर होगी। इसके साथ तो और धन्यवाद सर आपके सारगर्भित भाषण के लिए, और मैं आपको एज ए स्टूडेंट जानता हूं तो बहुत अच्छा लगा आपसे मिलकर वर्चुअल रूप में।
थैंक यू वेरी मच।
मैं आज के सभी पुरस्कार विजेता जिन सबको एनएमएल का प्राइज मिला है, अपने सभी वैज्ञानिक साथियों को और अपने सभी सहकर्मियों को जिन्होंने अपनी सेवा के लिए ये उत्कृष्ट सम्मान पाया है, हार्दिक धन्यवाद करता हूं और ये विश्वास करता हूं कि आगे आने वाले समय में आपका विज्ञान एवं कार्यालय के लिए योगदान ऐसे ही हम सबको मिलता रहेगा। उन सभी छात्रों को, बच्चों को बहुत बहुत शुभाशीष, शुभकामनाएं जिन्होंने ये मेरिटोरियस अवार्ड प्राप्त किया। साथ में बहुत बहुत शुभकामनाएं उनके माता पिता को जिनकी गाइडेंस में बच्चे इतना अच्छा कर रहे हैं। बहुत बहुत धन्यवाद आप सभी को। मैं अपने निदेशक महोदय का हार्दिक धन्यवाद देता हूं क्योंकि इस समय में, कोविड के समय में, इस तरह का ई प्रोग्राम सक्सेसफुली ऑर्गेनाइज करना, इसके पीछे उनका गाइडेंस, उनका एक डायरेक्शन रहा है और जिसका हमारे वो सभी साथी जिन्होंने आज के इस प्रोग्राम को ऑर्गेनाइज किया है, मैं एक दो का नाम नहीं लेना चाहूँगा, वो सभी टीम जो बैकग्राउंड में काम कर रही थी, वो सब धन्यवाद के पात्र हैं कि हम इतना अच्छा कार्यक्रम कर सके। और सबसे अंत में आप सभी का धन्यवाद जो इस कार्यक्रम से जुड़े और इस कार्यक्रम को सफल बनाया। तो एक बार आप सभी को नमस्कार, बहुत बहुत धन्यवाद।
Thank you very much.
Thank you, Dr. Sinha. Thank you for thanking everybody. Now, I have a small announcement. The award winners are all requested to assemble in Director's office for a photography session after this program. And now I'll request. Yes, sir.
In continuation of that, Professor Dwarkadasa, may I have your permission to hand over physically the award?
Yes, please. Please. They will all be waiting, and please hand it over. Thank you.
Right. Thank you, sir.
Okay. Now I would request all of you to please rise in honor of National Anthem.
Very good.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल नायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 जय